All right, MCT4C, day 4, lesson 1.3, finding angles. The 3-minute review goal is to use a calculator to evaluate trig ratios. So we can see, number one, we just want to fire some stuff into a calculator, and we'll hopefully see that there's some reason why we're doing this. So use a calculator and get that that one's 0.53, that this one's 0.53. This one ends up being negative 0.53. And this one's negative 0.53. And then number 2, we're asked to explain why the answers from number 1 make sense. And essentially the reason is because each of these angles, the 32, 148, 212, and 328, have the same reference angle, right? So let me draw this. Little unit circle here, get that going. Right, where if we had 32 degrees, has a reference angle 32 here, and the sine of that's 0.53, but the same thing over here, if this reference angle is 32, there, that angle, it's 148, also gives me a sine of 0.53, and of course we know because of the cast rule, that the sine is positive in this quadrant and this quadrant, and negative here and here, and that's exactly what we learned in number 1. Now, as far as a reason why that makes sense, I would say it's because we can say that they have the same reference angles. Oops. What's going on here? Here we go. Back at it. Have a reference angle of alpha equals, what is it, 32 degrees. Oops. Lovely. Question 3, if A is between 0 and 360, explain why that equation, sine A is equal to 0.53, has 2 solutions. When we saw this sort of thing in grade 10 when we're solving triangles, that sort of thing, we just fired into a calculator and it would give us the acute angle, it would give us the 32. But now we know that this actually has 2 solutions. One in the first quadrant because the sine's positive in the first quadrant, but also the second quadrant, the sine is positive. So the sine is positive in the first and second quadrant. That's why there's 2 solutions. So I'm just going to write sine of A is positive in quadrant 1 and quadrant 2. And in fact, that's what we're doing today in the lesson, is solving questions like that. So let's get on to it. The expectations determine measures of 2 angles from 0 to 360 for which the value of the given trig ratio is the same. So very similar thing to the 3-minute review. We want to find the values of theta that give us this relationship. So we know from what we've done before that there's probably 2 answers. And we know from the cast rule, and draw a diagram here, get us going. From the cast rule, since the sine is positive, our 2 solutions are in the first quadrant, and here somewhere. It doesn't matter how far we make that line, but we know it's sine is positive in the first quadrant and in the second quadrant, right? Because that's the cast rule. Write that in there just to remind everybody what we're doing. All in sine are positive first quadrant, second quadrant. So that gives me 2 possible solutions. First one in this quadrant, there's one of the solutions. I'm going to call that theta 1. We'll find that in a second. And a second solution right there is theta 2. And what we've been investigating yesterday is that these two angles, theta 1 and theta 2, have the same reference angle. So when we make like a grade 10 trig student and just fire this into a calculator like we are in a second, what we're going to do is we're just going to, you know, solve this as we would if this came up in a triangle, grade 10 trig triangle. And get theta alone as the inverse sine. That's the operation we do to both sides. Get our calculator out. Where's my calculator? And so I put in the 0.6788 inverse sine. It gives me 43 degrees. So that's actually gives me the reference angle, 43 degrees. I can see from this that theta 1 on my diagram is just that 43 degrees. And theta 2 is in the second quadrant, right? This is 43 here. So what's the value of theta 2? Well, it's 180 subtract the reference angle. And what's that? 180 subtract 43. Should be able to do that in my head. I'm a little bit embarrassed about that. 137. Good. We got another example here. Next slide. Okay, and we want to find the two values of theta where the cos of theta is 1 over the square root of 2. Now that should be ringing bells. That should be, you know, we should think of this as being an exact answer. And let's draw a diagram, get us started. We're thinking about, you know, where is the cosine negative, right? And what's the reference angle that's going to give us a cosine of 1 over the square root of 2? And there's a couple of ways to remember that. We'll get to that in a second. Now, where is the cosine negative? Well, it's positive here and here, so that means it's negative in these two quadrants, right? So that means our solutions have to be in the second and third quadrant. So I'm going to draw the diagram to show that. And here are our two solutions. One of them right there. Call that theta 1. One of them, green this time, eh? Right there. We'll call that theta 2. Okay, now, be exact means we should know what reference angle gives us this cosine relationship. And there's two ways to remember this. One of them is, well, the cosine is just the adjacent over the hypotenuse, and we could remember the triangle. Do you remember what triangle? You know, what's the reference angle here that gives us the adjacent over the hypotenuse is 1 over the square root of 2? Well, do you remember? If you do, you're good to go, because then you'll know what that reference angle is. The other way to do that is to come up with a chart, right? Or have that handy, the chart. I'm going to do it real quick. And remember, starts at 0, goes to 1, halfway between there, square root of everything, right? Square root of everything. Kind of a mess, but, and then this is the one we want, right? We want the cos that's going to give us 1 over the square root of 2. Here it is, right there. And remember, cosine is just the opposite direction of the sine. Tangent, we could fill in this. Maybe we'll need it later, but I'm just going to leave it for now because this is the one we want, right? And maybe you remember that without the table or without the triangle, that 1 over the square root of 2, the reference angle is 45, right? The reference angle is 45. Important, because as soon as we got that, we can know our reference angle is 45, and then we can get these two angles without a calculator, being exact. So down here, I'm just going to state my answers, right? Theta 1, that black one, is 180 subtract 45. And what's that? That's 135, isn't it? And theta 2 is 180 plus the reference angle 45, 225. All right, I'm going to stop her and go into part 2 in just a moment.